So now in today's video, we're going to take the NE5532 op amp here. It's a dual op amp. There's one op amp on this side, and there's an op amp on that side. So we're going to turn the multimeter to measure voltage, and we will see that at the rail here, we have 18 volts, just slightly above that. And this is going to be our 0 volt reference point. This is the output of one op amp. We have it wired as a voltage divider. So in relationship to this point here, we have 9 volts positive and we have 9 volts negative. And the way that we do that, it's a rail splitter made with one of the op amps. So here you can see two equal value resistors, 100 kilo ohms and 100 kilo ohms. One goes to the positive rail and then to the non-inverting input of that op amp. The other one to the negative rail and then to the non-inverting input. So that sets the voltage that the output wants to be. The inverting input right here, we have a little jumper right there, and that goes right to the output and connects it directly. And so since we're getting negative feedback directly to there, it lowers the voltage if it's higher than this point and raises the voltage if it's lower than the non-inverting input. So basically, since we have halfway between the rails right there, we'll get halfway between the rails there, and it will hold it there. That will become our virtual ground, our 0 volt reference point. And so we're thinking of that as 0 volts now instead of 9 volts out of 18. So in any case, we come back, we're going to provide a signal, a voltage with this trim pot. Coming up, we want to compare whether it is higher or lower than the voltage we set. We'll turn the meter off. And so, to do that, we're going to give negative feedback again. For the voltage first, let's do our load. That's going to be higher up on the board. So we want a red LED to light up when the output is higher than our virtual ground. So we're going to put the long lead, the anode, down one row. Short lead, the cathode, is going to this jumper, which leads back to our virtual ground right there. We're going to take a green LED and wire it the opposite way. So we want this to light up when the output is more negative than our virtual ground. So the cathode, short lead, is going to go down one row. The long lead, the anode, is going to our virtual ground right there. And we're going to protect these with a 1 kilo ohm resistor. And so that's just our load. It's just giving us a visual of what's going on. I do have the power on, and right now the output is high. So what we're going to do is that's just what it's doing right now. Everything's floating. It's not really wired up properly. Power should be turned off, but I'm going to wire it with the power on. So we have this, because I took the measurement of the virtual ground earlier. So we have a 1 kilo ohm resistor here. Value of the resistor really doesn't matter too much. We are going to put that to the inverting pin. So just like the left op amp here, the op amp on the right here is the non-inverting input, inverting input, and the output. We're going to take the resistor here, connect it to the virtual ground, and then to the inverting input right there. And then we are going to take our virtual, or our voltage that we can set here, our variable voltage. We're just using a trim pot. Practical circuit, you probably would not be using one. You'd be using something else that produces a voltage. And in this case, it's whether it's higher or lower than our virtual ground of 0 volts. And we will plug that to our non-inverting input right there, the bottom one. So the green LED is on. That tells me that the voltage set here is lower than 0 volts. And so if I turn this towards the positive rail, yep, I can see it's tilted slightly down. Just a little bit now. we have a slightly higher than 0 volt voltage. And we can take a look at that. So that's what the comparator does. And it's non-inverting when our input, our signal, is a higher voltage than our 0 volt reference point there. So 1.3, and it doesn't have to be the voltage drop of the LED higher. It's just any little bit higher or lower. So there we got 1.3, and this trim pot's getting kind of old, and the trim board, or the breadboard, is getting kind of worn on this side. I use it heavily, so it may be kind of glitchy where you kind of see an LED flicker, but for the most part this still works pretty good. So now we'll be slightly below 0 volts, and there you can see just a speck below. That's all we had to do, just a tiny bit below, and the output saturates. It goes completely to as far as it can go towards either the positive or negative rail. So there we got 0.226, so just barely crossed the line. Let's take a look at the actual voltage that the output is providing, because it doesn't usually go to either rail for most op amps. And so on the high side, out of 9 plus a little bit, it looks like we lost about a volt. And let's see what that was again. So 9.12, so about 9/10 of a volt or so we lost there. Let's lower this to, so we get a low output. There we go. And we can go all the way down to 0 volts if we want. It will keep the output low. Doesn't matter. Let's take a look at the voltage there. And you can see it's not as close to the rail. So 7.5, whereas at the negative rail we have pretty much spot on 9. So we lose about 1.5 volts trying to get to the negative rail. It can't get all the way to the negative rail. So that's because of semiconductors with voltage drops within them, and so those are topics to explore later. But in any case, that's the NE5532 wired as a non-inverting comparator. Thanks for watching. I will see you in the next video.